Hello everyone, I am Bhrigrishi Mishra from IIT Bombay, and this is the second online session of Elements of Solar Energy Conversion course. So the content of for week 2 there were 3 lectures and like 3, 4, 5. So for this online session I'll cover a few topics from lecture 3 and 4, and the remaining topics of lecture 4 and 5 will be covered by Mr. Pawan, whose online session held in the next week. So I'm covering following topics for this session: Sun-Earth relationship, tropics, relevant angles, different reference frames, connecting different reference frames, variation of declination angle. So from time, the next topic was time. So from time to lecture 5 topics that will be covered by Mr. Pawan in tomorrow's online session, which will be held from 6 to 7 p.m. every Saturday. So I have prepared few questions, but before going to that, we can look some basic thing which covered in this lecture, just to brush up your memory. And please note that this session is very important. I mean, this entire week 2 lectures, because the angles, the sun earth relationship described by few angles need to be understand very very clearly. Otherwise you will be in trouble to solve the question answer. Like, it is very important, these angles are very important to understand how the radiation is coming to the earth, how to calculate that radiation, where in which direction we should put our solar photovoltaic or solar thermal devices to extract the maximum amount of energy. So to understand these things, you first need to understand the angles. So let's start. So the first one is the solstice and equinox position. So as we have as discussed in the lecture, the earth's trajectory is elliptical and sun is on one of the foci. So there are 4 positions. One is the summer solstice, which is somewhere here, and earth is tilted 23.45 at its own degree, at its own axis, sorry. So this is one position, and this is another position. I'm just drawing the positions. This is just to brush up your memories before starting the question answer, so that you can understand question answer properly. Okay, so this one is called the summer solstice. This position is called the summer solstice, and it is on 21st June. So the sun rays are perpendicular to this point, and this, if we draw a line like this, sorry, it should be parallel to the equator. So this line is called the Tropic of Cancer, and beyond this line sun rays will never be perpendicular to the earth's surface. So this is the limit till which sun can be overhead to any point in this region. So this distance is the maximum distance toward north till when sun will be at overhead, or sun rays are perpendicular to the earth's surface. Similarly, for this case, if we draw the rays, if we extend this like this, so this point, and this is called the Tropic of Capricorn, and this position is called as winter solstice. It happens on 21st December. Okay, and this line is called the Tropic of Cancer. Again, beyond this line in the south direction, sun rays will never be incident on the perpendicular on the Earth's surface. Okay, so these two are the extreme positions. One is called summer solstice, where the length of the day is highest compared to the other days in the year, and this winter solstice is when the day is the shortest compared to any other day in the year. And these two positions are this first and second, these two positions are called the equinoxes. On these two positions, sun is at sun radiates beam perpendicular to the equatorial plane, that is sun is at the top of at overhead of the equatorial plane. So like this, so this is the sorry, so it's like this. So this is the equatorial plane. So sun radiates normally on the equatorial plane at equinox. So that is why at equinox the length of day and night are equal. Length of day and night are equal, and these two positions are called so this one is at 21st September and this one is at 21st March. So this is N S N S S. So these are the solstice and equinox position which we should remember, because so in a simple way I can say, if I draw a 2D diagram, so it's like this is Earth, so this is the equatorial plane, this is the north south axis, and these two parallel lines are called Tropic of Cancer, and this one is Tropic of Capricorn. So now we will talk about the angles. So there were 4 major angles which were discussed in the class. So angles, or the better way to say relevant angles between sun and Earth. So the first one is the latitude. So latitude describes the position of the observer at any point on the Earth with respect to the equatorial plane. So suppose this is Earth, and this is the center of the Earth, and this is the equatorial plane. So if the observer is at this point, this is observer means anything, any device like solar photovoltaic, solar thermal device, or anything, so which is called the observer. Even the places have their own latitude, longitude. So the angle it makes, the projection of this observer position makes an angle with the equatorial plane, and this is called the latitude, which is denoted as L. So this L angle is the latitude of the observer. So if you move to any other position of the earth, maybe your latitude different. I mean, there are points where the latitude are same, but depending upon your position, latitude changes. And we generally consider the objects or the observer in north is positive latitude. So objects in north has positive latitude and in south has negative latitude. The next angle is the zenith angle. So there are three angles: zenith angle and altitude angle, or you can call solar altitude angle, solar altitude angle, and solar azimuthal angle. Okay, so zenith angle, solar altitude angle, and solar azimuthal angle. So so suppose I can draw a plane like this, and this is like this is some surface, and this is the this is the zenith of the horizontal plane. That means the vertical line. So suppose I have this device, so the perpendicular to this plane is my zenith. So this line zenith is the vertical line, or you can say vertical plane on this horizontal plane. So now this is north south line, and this is east west line. So suppose sun is at here, suppose sun is at this place and it is radiating towards the earth. So consider a one sun ray which is incidenting this plane like this. So the angle of this sun ray makes with the zenith of the plane, of the horizontal plane, is known as zenith angle. So here theta z is the zenith angle. So okay, first I'll explain all the angles, then we'll write the definition of those angles. So now if I do the projection of this sun rays on the horizontal plane, so it is like this and like this. So this angle is known as the alpha, denoted as alpha, and known as the solar altitude angle. So theta z is the zenith angle and alpha is the solar altitude angle. And this projection of the sun makes an angle with the south direction, and this is called the solar azimuthal angle. So here AZ, it is also represented as gamma s, so this is called the solar azimuthal angle. Also in other textbooks it is also commonly represented as gamma s. So these three angles are very important and describes the position of the sun with respect to any horizontal plane on the earth. So if I have to write the, and yeah, this AZ, so in the so there are some sign conventions. So theta z in the east, theta z is positive if it is measured in the east, and negative if it is measured in the west. Okay, similarly AZ, so AZ is positive when it is measured in the west of south. Okay, that means here this position west of south means this one, it is measured as positive, and negative when measured in the east of south. Now if I write the definitions of these three angles theta z, that means zenith angle, or I can simply write zenith angle theta z. So this is the angle between the vertical line of the horizontal plane of the horizontal plane on the earth, vertical line, and the line to the sun. It describes the angle of incidence of beam radiation on a horizontal surface. Second one is solar altitude angle, which is noted as alpha. So it is the angle between the horizontal and the line to the sun. Line to the sun means the path of the beam radiation hitting the horizontal plane or horizontal surface. The last one is solar azimuthal angle AZ, and this is the projection, the angular displacement. The definition is the angular displacement of the projection of incident beam radiation on the horizontal plane from south. This we need to remember, like remember that the solar azimuthal angle is the angle between the projection of the sun on the horizontal surface to the south line. So it always measure with the south, okay, not with any north, east or west, only from the south. The other angle is the declination angle. So declination angle is the angular position of the sun at solar node when sun is at the top of the head with respect to the plane of the equatorial. So suppose north south, and this is the equatorial plane. So suppose sun is here and sun ray is coming like this. So the angle it makes, this is called the delta declination angle. This is sun. Okay, so this angle is known as the declination angle or denoted as delta. So at summer solstice, so delta ranges from minus 23.45 degree to plus 23.45 degree. At summer solstice, we'll talk about it later also. So this is the range of the declination angle, minus 23.45 degree less or equal delta less or equals 23.45 degree. So these are the main angle: latitude, zenith angle, solar altitude angle, azimuthal angle, and the declination angle. These 5 angle we need to understand very clearly. It will help a lot to understand any problem, any real life problem, or if we need to calculate the amount of solar radiation coming to the surface, what should be the position or the orientation of the solar cell to get to harness solar radiation maximum. So please remember these angles. Like you need to imagine a 3D view to understand these angles in a better way. You try to draw it multiple times to understand it. Okay, so we'll start with the problems. I have taken 6 or 7 problems for this session. So first one is, which is correct for latitude? So L minus 180 to plus 180, minus 90 to plus 90, minus 180 to plus 180, like less than, these are less or equal, and these are the less. So as we have seen, the latitude is the observer location with respect to the equatorial plane. So this is center of Earth and this is the plane observer position, and this angle is denoted as latitude. So imagine like this way, that there are lot of points here. So it can go from this to this, or like the same way from the bottom side also. It can go from here to here. So what should be the latitude? So clearly it is 0 when lies at equator, and here also it is around 180 degree, but what about this place and what about this place? This is 90, 0, 180. So from 0 to 180 it goes in one hemisphere, and minus 180 to 0 it goes from another hemisphere. So clearly latitude is it's 0 to 90 here in this half, and minus 90 to 0 in this half. Similarly for the southern hemisphere also. So it is minus 90 degree to plus 90 degree. This is the latitude. So latitude varies from minus 90 to plus 90. Now the next one is, which is correct for solar azimuthal angle. So for the azimuthal angle, this is we have talked about. So this is the azimuthal angle, this one. The projection of the sun makes it with the south line. So we can understand it in a better way, suppose in a 2D diagram, this is north, south, east, west, and suppose the sun is here, and this is the line of projection of the sun to the horizontal plane. So this angle is this angle is azimuthal angle. So clearly it can vary like 0 to 180, like as I have mentioned here. It is positive when west of south and negative when east of south. So it's not 0 to 360 degree, it's 0 to 180 and then minus 180 to 0. So when it is in west of south, that means here in this portion it is positive, and when it is east of south, that means here it will be negative. So it can vary from 0 to 0 here to 180 here, and similarly just when it comes in the east south, then it will be minus 180 to here again 0. So the correct answer is minus 180 less or equal to AZ less or equals to plus 180. So the next question is, for tropical latitudes, when will AZ be minus 180 degree and when plus 180 degree? So what is tropical latitude? So tropical latitude are basically Tropic of Cancer and Tropic of Capricorn. So at these positions, sun is at the overhead, that means at the top up, and radiates normally to the earth's surface. So in these two cases, theta z or the zenith angle is 0 degree. So if it is 0 degree, that means if I draw the diagram again, so this is north, south, east, west. So at zenith, that is for tropical latitudes, the sun will be like here, somewhere here. So the angle it extends is just before noon. So just before noon it will be in the east and south. So just before noon, that means the angle it makes is sorry, not from here, but from here. Okay, so here, so this and this is not. So just before the noon it is because sun rises from the east and goes like this way. So that is why at solar noon the position is at here, not here, which I drawn earlier. So that was wrong. So when sun rises at east, this position, and at solar noon it will be directly overhead to this position, to the center. So the angle it makes with the south is 180 degree. Okay, but here it is asking minus 180 and plus 180. So just before noon it will be in the east south quadrant, and in east south quadrant the azimuthal angle is negative. So just before noon AZ will be negative, and just after noon AZ will be 180. So AZ equals to minus 180 degree just before noon. Why? Since it is in east south, and AZ equals to plus 180 degree just after noon. Why? Because since it is in west south. Okay, so the correct answer is A, just before noon and just after noon. And as sun's position changes, the altitude the azimuthal angle changes. The next question is, what is the zenith angle at sunrise and at sunset? So if we draw the 2D diagram for the zenith angle, so for example, this is north, south, east, west, and suppose sun is somewhere at here, so this angle making with the north, this is called the zenith angle. So when at sunrise the sun position is here in the east direction, so this angle will be 90 degree, and when it is in at sunset, it all the ways goes like this. So this, then this angle will be again 90 degree, because we are considering it from this north south line. Now the question is, both can't be 90 degree, and since we already told that the solar this zenith angle positive in the east quadrant and negative in the west. So that means at here, at this position, at sunrise it is plus 90 degree, and at sunset it is minus 90 degree. So the correct option is option B, plus 90 degree and minus 90 degree. Okay, now the next question is, derive the relation among latitude, declination angle and zenith angle. So one thing, like zenith angle and latitude and solar altitude angle, these are the angles in the vertical plane, and the solar azimuth angle is angle on the horizontal plane. So you need to remember this. So we can derive the relation. So first we can schematically show in the angles here. So latitude is like if this is the position of the observer, sorry, it's this line, and this is the latitude angle. A declination angle is similarly like this, and this is the equatorial plane, and the sun rays are coming like this. So this angle is the declination angle, and the zenith angle. So for the zenith angle, so again sun is here, so the angle it makes with the north south line, or the vertical line of the horizontal plane, is the zenith angle, theta z. So these are three different angles, and we need to find the relation between these three angles for a horizontal plane. Okay, so it is better to draw all the three angles in a single diagram. So for that can draw this. So for example, suppose we have this earth, this is north and south, and this is the Tropic of Cancer, this is equator, and this is Tropic of Capricorn. Okay, so suppose the horizontal plane is somewhere here. Okay, so the perpendicular line is like this. Okay, and this angle is latitude. Okay, this is the latitude angle. Now suppose sun is somewhere here, and it is the sun rays are parallel to each other. So suppose this is one sun ray and this is another sun rays, so these are parallel to each other. So I can use a different color. So this angle is the theta z, because this is sun and this is the plane or horizontal plane on the earth's surface. So the angle between the normal to the horizontal plane to the sun ray is theta z, zenith angle. And now this another parallel ray, sun ray, making an angle with the center of the earth, this is called the declination angle, delta. So this is a single diagram in which we have incorporated all the three angles. To make it in a better way, I can draw separately, like for example, this is the common line, and this is this line, and there is these are two parallel rays. Okay, so this one is the I should use a different color, sorry for that. Let me draw it again. So this is the equator, this is the equator line, and this please mute yourself. Mr. Paresh, please mute yourself. Yeah, thanks. So now this, and somewhere here my object is, so this is the normal line and this angle is the latitude. Okay, now if I draw the sun rays, so sun is somewhere here and it is emitting parallel lines. So this one line makes an angle with the normal of the surface, is known as theta z, and another line which is again parallel to this, it makes this angle, this is the delta. So if I draw a line here, it completes a triangle. Okay, so if I name the position, suppose this is A, B, C, D, E and F. Okay, so this complete angle is L and this is a delta. So this angle will be L minus delta. Okay, so if I can pick the two triangles like this, A, F, B, this is more sort of geometrical thing to draw. I mean, it can the relation between these three can also be derived from the formula, but that we will study later. So here I am just showing the derivation using geometrically. Okay, so this is the theta z, and another triangle is AEC, and this is L minus delta. So as you can see, this AF and A, these are like the same lines, so AF parallel to A means the A is the extended line of AF, so these two are parallel to each other. And also this sun ray, so this OB, so this OB and or FB, I can say FB, and this FC, sorry EC, these two are also the sun rays, and sun rays are parallel to each other, so FB parallel to EC. Okay, and similarly this AB and BC, again this sorry, AC is the extended line of AB, so AB is parallel to AC. So three lines are all the three lines of the triangle are parallel, so that means the two triangles are similar triangles, and thus their angles are equal. So in that way I can say that angle AC, sorry, angle ABF equal to angle ACE, which is thus theta z equals to L minus delta. So this is the relation between zenith angle, latitude, and declination angle. Now so in northern hemisphere, theta 2 equals to L minus delta, okay, sorry, theta z, and in southern hemisphere, so delta will be minus delta and L will be minus L, so theta z will be minus L plus delta. This is in the southern hemisphere. Okay, so in the northern simply L minus delta, and in the southern hemisphere minus L plus delta or delta minus L, which way you want to represent it. Okay, so this is the derivation of like the relation between zenith angle, declination angle, and the latitude. Okay, so if you guys have any question you can ask, or I'll move to the another problem. Okay, so what is the value of declination angle at summer solstice in southern hemisphere? So I can again explain it. So for example, so now I can simply draw a more 2D. This is the equator, this is the Cancer, Tropic of Cancer, and this is Tropic of Capricorn, and sun is somewhere here, say. So this angle, this is sun, so this angle is a delta, declination angle. So the maximum angle it subtends is here, sun radiates normally to this plane, Tropic of Cancer, and beyond that sun rays will never be perpendicular to the earth's surface. So this is the maximum till it reach, and in southern hemisphere this position is the maximum position till it reach. So if sun is here, so this is the maximum delta, so this is the max delta, and similarly here also this is max in southern hemisphere. Okay, so and the latitude of Tropic of Cancer is 23.45 degree, and the latitude of Capricorn is minus 23.45 degree. So that is why delta varies from minus 23.45 degree to plus 23.45 degree. Okay, so at this point, when sun is when sun radiates perpendicularly at Tropic of Cancer, the delta is maximum plus 23.45 degree. When sun radiates perpendicular at Tropic of Capricorn, the delta is minimum minus 23.45 degree. And when sun is in line with the equator like this in the two equinox position, the delta will be 0. So at equinoxes delta will be 0. Okay, now this is with respect to the northern hemisphere. This is with respect to northern hemisphere. So the summer solstice in northern hemisphere is winter solstice in southern hemisphere, and winter solstice in northern hemisphere is equivalent to summer solstice in southern hemisphere. Okay, so at summer solstice, which is this position, this one, so at summer solstice the delta is minimum, that is minus 23.45 degree in winter solstice in northern hemisphere. So the winter solstice in northern hemisphere is summer solstice in southern hemisphere. So the correct answer is option B, minus 23.45 degree. So this is the declination angle at summer solstice in southern hemisphere. Okay, this is the last question of this session. So find the day of the year on which the sun is at zenith angle of 22.3 degree at Mumbai, 19 degrees 7 minutes north. This is the latitude of the Mumbai, so can calculate it. So first we need to convert this latitude in degree, like it is given in degree and minute. So the latitude L is 19 degrees 7 minutes. Now 60 minutes comprised to 1 degree. Okay, so 1 minute comprised to 1 by 60 degree, and thus 7 minute equivalent to 7 by 60 degree, which is equivalent to just a minute, I can calculate it. Oh wait, I have calculated somewhere here. Okay, yeah, so it is 0.116 degree. So the latitude is 19.116 degree, or I can write it like 19.12 degree, although it is a significant change. I mean, not very significant, but yeah, it affects the location on the earth, but for the calculation we are taking it we are taking the simplification value. But for the real life problem, you should not take this kind of simplification and use whatever the value is given. Okay, means if it is 19.116 degree, you should use 19.116 degree, not 19.12 degree for the real life problem. Okay, so this is the latitude. Now here it is given, find the day of the year on which the sun is at zenith angle of 22.3 degree. So when the sun is at zenith angle, okay, the relationship between zenith angle, latitude and declination angle we have already derived, which is theta z equals to L minus delta. So theta z equals to L minus delta, and we need to calculate delta, which is declination angle. It is nothing but L minus theta z, and the L is, you have calculated 19.12 degree, and theta z is minus 22.3 degree. So the difference is around minus 3.18 degree. Now the formula to calculate declination angle of the any day of the year is given as delta equals to 23.45 sine 360 by 365 284 plus n, and we need to calculate this n. This is the n we need to find out for the given zenith angle and the latitude, that is for Mumbai. Okay, so let's equate these two, this expression with this value we calculated from the from this relation. So it is simply 23.45 sine, and we can simplify this. 360 by 365 is 0.986, sorry, 0.986, 284 plus n equals to minus 3.18 degree. So it is sine 0.986 284 plus n, and when we divide this, it gives the value of around minus 0.1356. Take the sine inverse, okay, sine inverse, and also multiplying in the values inside the bracket. So it comes up around 280.1 plus 0.986 n, and the inverse is 0.1356. Now the sine inverse of if you calculate the sine inverse, so sine inverse of minus x is minus sine inverse x. So sine inverse of minus x is minus sine inverse x. So similarly, if we calculate sine inverse of this, we simply need to calculate sine inverse of 0.1356, which is so it is 280 plus 1 plus 0.986 n, and this is minus 7.79. so minus 7.79, also clear, this is minus 7.79, which is greater than 1. So please do not confuse that this is the angle theta, which can be anything like minus 180 to plus 180, 0 to 180, or any angle it can be. Okay, since it is periodic, so we consider it from 0 to 180 degree, or minus, or like in the minus, but here it is simply minus 7.79. so since this is theta, it can be greater than 1 or it can be less than minus 1. Okay, and this, yeah, okay, that's it. So sorry, not this angle, but this entire value, okay, this entire value is simply theta, okay, not the inside value. Inside is the range, so it's sine theta equals to, for example, some x, so theta is sine inverse x. Okay, so here x has the range of minus 1 to 1, but theta is periodic and can have any range, okay, minus 180 to plus 180 or 0 to 180, something like that. So this value is theta, not the x. Okay, that is why it can be greater than 1 or less than minus 1. So this is minus 7.79, sine inverse of minus 0.1356. So now if we solve this, we will get n equals to minus 287.89 divided by divided by 0.986. so it is 291.97, or simply I can say n equals to 292. Okay, now this is minus 292. So but number of days cannot be negative. So if the n value comes negative, you have to add plus 365 to get the actual number of day or the day. So okay, so here the n will be 365 plus minus 292, so it comes around 73. So n is 73, and if you calculate it, the number of days, like n equals to 1 is 1st January. Okay, so n equals to 31 when this is 31st January, and at so February is 28. So at 28th February, n will be 31 plus 2 weight equals to 59. Okay, so from 60th 1st March starts, so it is 73. So n equals to 73 minus 59, which is 14. So that means it is 14th March. Okay, so n73 corresponds to 14th March. That means so it is the 14th March of the year on which the sun is at zenith angle of this at Mumbai. Okay, so in this way you can calculate the n, or the number of day. But please remember, if you are getting n negative, no need to worry about it. You can simply add the 365 to get the actual number of day. Okay, so yeah, that's it from my side. So if you have any question, please ask. Okay, so hello.
Thank you, sir.
Yeah, okay, if you have no question, I'll stop it here, and you can find the recording on the YouTube channel. Probably the NPTEL guys will send you the link of the YouTube lectures. Okay, so if you want to rewatch it, you can rewatch.